Just imagine, the projection is by 2030, the US power grid may be as much as 8%, right, data centers. If you're living in that world and you believe this digitalization goes on, right, then every year from 2030 on, it's 2% or more in the national power grid. This is an amazing, transformative kind of change if we're going to chase this. Now, it's always dangerous to predict exponentials 2 years out, much less 7 years out. But if we really believe that AI is going to become what we're hoping it will become, that's the kind of scenarios we're looking at. So what problems is this causing? This has to do with the role I think HPC has to play in this space. So HPC simulation and AI training is causing power problems with the grid.
GPT-4 is actually training GPT-4 consumed more than 1 week of Frontier, which used to be the fastest supercomputer in the world as of up until this week. They're driving a huge influx of money that will help the HPC community basically by having access to photonics. There's so many things as an HPC guy, I've been dreaming about for over a decade that are now about to happen because of the influx of money that large-scale AI is now driving. So it's not all bad. One of the other kind of hockey stick curve, I kind of like that one on the right, that's showing that now all the data centers in the world actually have a power consumption that's larger than Italy. So there's only 4 countries in the world today that consume more power than the sum of data centers.
If you look at the progress of Moore's Law over the last 50 or 60 years, the increases in energy efficiency are astronomical. Many, many orders of magnitude, I don't know, 10, 12, 15. So any amount of efficiency increase could still lead to massive growth in consumption and massive growth in environmental damage. So I think that we have to face the reality that society is likely at some point to start pressing on us to say, it's not good enough that you're a little bit more sustainable, You have to find a way to contain the overall environmental impact of all of the activity of all of computing. And HPC is a piece of that, cloud is a piece of that, mobile devices are a piece of that. And that constraint becomes much more severe. So I think the bar is very high for what we, as a community, need to achieve over the next 5 to 10 years.
So, cooling towers, you see them on the roof of this diagram here. This shows a picture of our data center. And in fact, one of the things I like to point out is that Frontier is this tiny little black piece right over here. But this whole big thing is all the data center. It's a huge amount of infrastructure that's required to run these things, but you have all of these cooling towers sitting on the roof, and they work by evaporating water. So water gets evaporated, it's gone. It came out of the water pipes, and now it's gone. How much do you lose in a data center? Well, it turns out that in our data center, we use about 100,000 gallons a day that are just evaporated into the air. Now, we use a lot more water than that, as you were saying, pumping the water out of the river. How much is that? Well, the Ornell Data Center pumps about 6,000 gallons a minute through Frontier to keep it cool. But out of that, another 100,000 gallons a day is just evaporated into the air and lost.
We really know that water scarcity is becoming a bigger issue. We've seen that with climate change, and we want to make sure that we can also have our resilient infrastructure. So what we've decided to do at Los Alamos is, this is our water balance, and basically we run our data center, our biggest data center, with reclaimed water. And basically we do that with our SURF facility, so it's the Sanitary Effluent Reclamation Facility.
The question being, are we really missing an opportunity, particularly for this community, where we look at, I kind of look at the metrics and go, you've got traditional facilities metrics, you've got sustainability metrics, you're starting to blend those things. At the end of the day, does the researcher who's wanting to get the application through the system really care? And so should we really be looking at things like, carbon intensity of the job, energy intensity of the job, how do we expose that to the user community so that they can start to make the right decisions? And maybe we posit, tomatoes per job.
So it nets out to 1 million tomatoes for training ChatGPT once. So
I kind of use an illustrative example to get you guys to it's kind of funny, but the math actually works, and that's the kind of mindset I think we need to get into as a community, not just about no water use and limiting the electricity use, but also really trying to tie that into a broader ecosystem.
I mean, we all know metrics reward and punish, and people optimize to the metrics to which they're exposed.
All data center operators are in a different spot with regards to measuring sustainability, and so we've broken it out into kind of 3 categories depending on where you're starting. From the beginning, where you'd maybe take a look at 6 out of the 28 metrics that we think would be great to measure, advanced 18, and leading would be 28. And my proposition is that the HPC community should be striving to be leading. They lead in all the other aspects of performance, and I think sustainability reporting and measuring should be one of them.
Well, the real metric that we need is to find out what is the purpose of these HPC systems and put that in the numerator. For me, at a leadership computing facility, it's how much science gets done. If I can somehow improve my application algorithms so I can get twice as much science done, and the machine is still using the same 20 megawatts, I've actually improved sustainability by getting more work done for that particular case. Or if I'm training AI models, again, there are ways of balancing out the useful work over the energy.
So the road to the future, right, off in the distance, the sunny future, is both windy, of course windy, right, that's a pun there, and green, right? So that's how I think about it. So the real challenges in making this work is how do you make the economics work?
If you look at the distribution of power prices for wholesale markets, the price of power varies widely in most power markets. And in many power markets, you can get 90% reduction in your power costs and average price per megawatt hour if you are willing to sacrifice some small percentage of unavailability.
So, you know, we're still living in, I think, a hangover of data center designs based upon the financial industry of the 1980s and 1990s, right, with regards to 7x24 availability and all that stuff. So, and it is tough, right, for the engineering community broad to try to get out of that and understand that there might be levels below that that are going to be okay.
The challenges I think we face is I don't think you should expect that the companies or the industry is going to solve this problem by itself. Though there are many good-intentioned, you know, and highly ethical people in industry, it's very difficult given the market competition and the profit incentives. So we need a strong advocacy by the general population. We need good public policy to support that progress. And then it'll be amazing the things that the industry is capable of.
But I would encourage you as you leave to think about this. As we think about problem solutions, and this last question was a great example of it, we think about them within the context of some bounding box. These problems, as Andrew rightly noted, are complex social, industrial, policy, economic, technical, and engineering issues. You got to see the whole board as you think about the solution. All right, thank you all.